So this video I'm going to be talking about the surface area and volume of prisms. So one thing about prisms is, they're basically three-dimensional objects. So here, horrible description, I know. Here we have a prism, and you may remember this from science class where if we shine white light through this crystalline prism, we get the full spectrum of colors. Awesome, cool stuff. So what exactly is a prism? Well, a prism is nothing more than a two-dimensional shape with a uniform depth. So if we look here, this is a triangular prism because we can see we have this triangle there. Now imagine in the screen we had this triangle and then we pulled it directly out. Then it would now have depth. And because it's a uniform depth from all points, all corners on that triangle, it now makes it a three-dimensional object, which we call the prism. So this is a triangular prism. We could have a rectangular prism. Basically, we have a three-dimensional object from any two-dimensional shape you can think of with depth. So for example, if you think about a stop sign, which is an octagon, you can have an octagonal prism, which is horribly drawn there. We won't be getting too much into the complexities of the different types of prisms because we're just going to be sticking with the basic prisms and finding the surface area and the volume. Surface area is nothing more than the area of all the surfaces. If we look at this triangular prism, again, you can see we have two triangles on the opposite sides, and then there are actually three rectangular faces here. There's that back face, here's that one on the top, and then there's this bottom rectangular face. So there are three rectangular faces and two triangular faces. If I want to find the surface area, that's nothing more than all those individual areas added up. If we have difficulty with that, we can make what's called a net. So, for example, if I have a cube, right? This is a 3D object, it's a cube, it's a square with depth. We could make a cube because what we could do is we could say, oh, well, if I unfold that cube, then what I have is all these squares that if I just fold them back up, they make a cube. This is a net. Now I will be making nets. I'm going to be using just eyesight and visual, and just looking visually to try and find these prisms in the surface area. But if you struggle with this, absolutely go back and try and make nets. And definitely ask me, how can we make nets? And I will go through that. All right, so that's the surface area. The volume is nothing more than the area of the base times that height or depth. So here we have this triangle. So to find the volume, what we want to do is we want to find this area and then multiply it by the depth. And so imagine we take an infinite amount of triangles in here that we're just, continually adding on top. That's really what the volume represents. So let's look at some examples because I think that might make a little bit more sense. So here we have two triangular prisms, a rectangular prism, and here because we have this face there, that is a trapezoid, we have a trapezoidal prism. So here we have this triangular prism, and we want to find the surface area. So again, it's going to be the area of all the surfaces. If I look at this back triangle here, it's a right triangle, so that means that I could say that this distance here is my base, and this distance here is my height. So it's going to be 1/2 times the base. Well, if I look, this distance is 3, so this parallel distance, opposite side of this rectangle, it's also going to be 3. So 1/2 times the base, which is 3, times the height, which in this case is 4. Now, in prisms, the opposite sides are going to be congruent. So this triangle, this opposite face, is congruent to the other triangle. So see, it still has this base of 3 and this height of 4. So to find the area, we do 1/2 of base times height, or 1/2 of 3 times 4. Now I have to add the areas of the 3 rectangular faces. So if I look at this rectangular face in the back, I can see that it has this base of 5 and this height of 3. So that area is going to be 3 times 5. If I look at this top rectangle, that has an area that's 4 times 5. And then I have this bottom rectangle, which is going to have the area of 5. And again, because this is 5, that means that this distance is 5. So this bottom rectangle is actually also a square. Yeah, that should be a 5. Okay. So we have half of 12 plus half of 12. Well, that just gives me 12. Plus 15 is 27. Plus 20 is 47. Plus 25 is 72. So that's the surface area. And because it's area, these are in yards, it's yards squared. Surface area is just all the areas added together. So of course it's going to be yards squared. Okay. Next up is this. So this might look a little bit weirder, but here we can see this height. So remember, the formula for the area of a trapezoid is 1/2 the height times base 1 plus base 2. So we're going to have 1/2 of the height, which here is 2.6, times base 1, which this distance here is going to be 8, because this distance to the back is 8, plus base 2, which is 5. And we're going to add the area of the other trapezoid in the back. Again, these opposite faces are going to be congruent areas, congruent trapezoids. So once I get those, I have 2 rectangles and two rectangles on the sides and 2 rectangles on the top and the bottom. So I have, again, this distance is 8, so that means that this length is also 8. So that side rectangle is going to be 8 times 3. And this rectangle here, we can see we actually, if you look closely, we have these congruent marks. So that means that this distance is also 3. So we have another 8 by 3 rectangle on the other side. If I look at this top picture, I have this rectangle here, which is 8 times 8. So again, another square. And then this bottom rectangle, that's a distance of 5. But we know that this already is a distance of 8. So it's 5 by 8. And so there we have all of those surface areas to add up. So we're going to have 2.6 times the 8 plus 5. And we're going to take that, divide it by 2. But if you notice, we're adding half of it and half of it, so we might as well just add the same thing. And that's 33.8. And then we add the 24 plus 24 plus 64 plus 40. And yeah, that gives us a grand total of 185.8. And again, kilometers squared, because we're talking about area. Now volume is a little bit different because we want to find the area of the base. And so for this triangular prism, it's the area of this triangle base. And we want to multiply that by the height, or the depth, which here is 2 feet. So we're going to do 1/2 times the base, which we could say is 3, times the height, which is 4, times this depth or height, which is 2 here. So this is going to give us a volume of 12. Now because volume deals with 3 dimensions, that means that we're not going to have feet squared, we have feet cubed. So volume is always the units cubed. For here, it doesn't matter for a rectangular prism, which we say is the front face, because again, volume is just the three distances measured or multiplied together. So whatever we call the length, the width, the height, doesn't matter. So here we have 4 times 9, we can say is our primary base. And we multiply that by the height, which here we can say is 6. So we get 36 times 6, which is 216, again, centimeters cubed, because this is volume and volume is cubed. So this is surface area and volume of prisms, which may be one of the more difficult topics, only in trying to visualize these. But once you can visualize them, it's actually a nice, simple process. If you do have difficulty trying to picture them, then we can start looking at how to make nets of these prisms that may help you. So we'll look at those, and let me know if you have any questions.